So to graph a rational function that looks like this, the first thing that you want to do is factor. Look upstairs, look downstairs, and factor everything as much as you can. So we took out a 2 from the front, and then this trinomial here broke down even further into these two pieces. The bottom was just a difference of squares. Once it's fully factored, we can find quite a few pieces. First, we can begin with the x-intercepts. So recall that the x-intercepts are whatever makes the top 0. So what would make this factor 0? -5. What would make this factor 0? 2. Notice that if there is a constant in the front, that number does not give you any x-intercepts at all. X-intercepts only come from factors which have variables like x's. Now, for the bottom, whatever makes the bottom 0, those are what we call the vertical asymptotes. And I use the abbreviation VA for vertical asymptotes, so 3 and -3. Now, the more complicated one would be the horizontal asymptote. How in the world did I get to? Well, look at the original problem. What is the degree of the top? 2. What is the degree of the bottom? 2. So it's a tie. Anytime it's a tie, what you do is you take the front numbers and divide them. So that's a 2, and there's an invisible 1. So 2 divided by that invisible 1 is just 2. Now that we have the asymptotes and the x and y intercepts, what we can do, well, we didn't find the y-intercept, did we? But maybe we can get that later. So what we can do now is make a picture. And maybe you can take your vertical asymptotes and draw those vertical lines. Make them dotted. Always make asymptotes dotted. Here's 2, the horizontal. Now, I have the x-intercepts, -5 and 2. So boom, boom, couple of points. Now a table. What x values should we use? Well, that'll change from problem to problem. It all depends on what you have and where you're positioned. I'd like some x's from here. I'd like maybe some x's from here. And I'd like some x's from this section. So this one's -5. Maybe I can sort of go down the road and use like -9. And then maybe for the middle piece, maybe I can use like -2, and maybe I can use like 0. And for this portion over here, maybe I can use a couple of x's and just spread them out a little bit. So I've decided to use these x's. So now take them and plug them into probably the original if you want. So take -9, plug it in there, and here. Use parentheses carefully on your Casios, and you'll get back this particular value, along with all these other x values, or y values, I should say. Now take these x and y coordinates, which are ordered pairs, and scatter these points on your grid. I have 5 new points that are introduced. Boom, 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 boom. They're all there. Now just connect the dots, and you're done. So in this section here, I would connect these points with something that looks like that. Recall that each segment of the picture is likely to hug the asymptotes. Put arrows, boom, boom. Now for the middle piece, for these 3 points, if you used more points, you would discover that they should be connected in sort of a zigzag type of fashion. Put arrows, boom, boom. And then for this piece here, just connect them in a sort of natural way, right? Just instinctively you'd think it looks something like this. So do so and put arrows. We're done, we're finished. Now, what if as bonus questions, they asked you to answer things like the domain, the range, the intervals of continuity and behavior, and intervals of increase and decrease? Well, now that your picture is complete, we're better equipped to answer things of this sort. But for now, I'll just cut off the video here, because this is how we graph. We factor everything, we find intercepts and asymptotes, we plot the intercepts and asymptotes, and we connect the dots. Notice that we got the y-intercept sort of as a bonus here, but maybe we should have found the y-intercept earlier in the problem, but either way, we completed our task.